Hey everybody, this is Josh Stinson with CodeEnvy. For the best viewing experience, please set this streaming presentation quality manually to 720p. In this session, we have our presenters, Jonas Helming with Eclipse Source. We've got Kalayan Reeve with Zend. And then we've got our very own Stephen Lemure, whose birthday it is today. So everyone wish him a happy birthday. And he's with CodeEnvy. And we're going to share with you the presentation on extending Che. So, Stephen, take it away.
So, thanks, Josh. So, hi, good afternoon, everyone. Thanks for joining us this afternoon at this CheConf session about Che extensibility model. We will discuss about plugin and extension authoring, but before that, I'd like to introduce the speakers. So I'm really pleased to welcome two guests to speak about some concrete use case of Che extensions. Jonas Helming from Eclipse Source and Kalayan Reeve from Zend, a RogueWave software company. So the agenda for this session will start with an overview of Che architecture, what parts can be extended, and how you can extend it. We will do an Hello World extension as well. And then we will dive a little bit deeper into Che core by exploring two use cases. The first one will be by Jonas about building an e-core editor. And the second one will be about adding the support of PHP to Che. And this will be handled by Kalayan. So let's go. So Che architecture, as you know, Che is a workspace server. It manages all the workspace lifecycle. It also orchestrates the workspaces between each others. And Che injects various services into each of the workspaces. So it mounts the project source code. It injects Che plugins. It injects also SSH daemon and agents for IntelliSense, like for the JDT, for example. The workspace also contains a synchronizer. So for the user who is running his workspace, either locally or remotely, it will keep the files in sync while the workspace is running. And then you have the browser IDE. So the browser IDE is composed of the Orion editor, which you are using when you are editing files. It also has a lot of panels, menus, and widgets, and all the Che plugins. So the browser IDE is a web application, and it is written in Git. The browser IDE is communicating with the Che server through REST APIs or WebSockets. So it can communicate with Che server, but it can also invoke services that are running directly inside of the workspace machine, like the agents for the code completions or the code analysis. So that's the basics. There are few ways you can extend Che. You can create IDE extension. You can modify the look and feel, of course. You can create panels, you can create editors, menus, or toolbars. And most of those extensions are written in Git, as I mentioned it. But you can also do that with native JavaScript, and Jonas will speak about that in a few minutes. So, of course, you can also modify the core of Che. You can add or modify the APIs. You can change the way the Che server is operating. You can also add developer services that are running in the workspaces. And we are used to call them the workspace agents. So the agents are packaged as a script that are executed after a workspace machine is created. You can have agents to allow terminal access, to allow SSH, but you can also have agents for providing extended developer services like the language servers. So the language servers provide IntelliSense capabilities for PHP, C#, and JSON, for example, and they are packaged as agents, so they are running directly inside of the workspace runtime. So there are many ways to extend Che and its capabilities. You can, like SAP, use Che server for the workspace provisioning and the management of all those workspaces, and create your own custom IDE UI and communicate only over REST APIs with the Che server. Or you can create IDE extension to integrate with third-party services, like Red Hat did with the OpenShift plugin. So it is a set of wizards and UI to be able to connect with the OpenShift path. Or you can take Che and you can create a completely customized and personalized experience. You can remove actions, you can create custom actions, for example, as well. And it's what Nuxeo did with their certification center. So there are many ways and number of ways you can extend Che, but how it will look. So let's do a quick Hello World plugin, and the very basic steps are to create a new Maven project. Then we will create a singleton extension. We will then create the GUID module and then register the extension inside of Che. So once I will have created my Maven project, I will create a Java class. Inside of this Java class, there are two annotations that are very important. The first one is @singleton, which is required because in the case the instance is triggered several times, this extension will need to be initialized only one time. Then there is another annotation which is important. It's the @extension. It has some metadata, the title, and the version. And it lets Che application know this is an extension and the code will be executed when launched. In the constructor of my Hello World class, I will get the notification manager, and the notification manager will be used to display a small Hello World message in the IDE UI. It will be displayed in the event panel. Then I will create my GUID module. So it is an empty module which inherits from the Che IDE APIs. So this way I can get the notification manager. But it is empty because there is no custom UI with this extension. So we are just reusing the API to display a small message, and the API is the notification manager. Once I have my Hello World plugin create, I will build it. So it is a Maven artifact. So I just need to do a Maven clean install of my Hello World extension. But now I have to register my plugin. So as it is a Maven artifact, I need to add the Maven dependency inside of Che. So I will add the dependency to the root pom.xml of my Che. I will link my artifact inside of the IDE assembly. So because it is an extension which will affect the UI of the IDE, I will add the dependency to the assembly IDE war. And then I will also add the GUID module to the IDE GUID application. So the IDE GUID application is inside of the assembly IDE war, and I will inject my extension there. Once I have this done, I have my sample plugin that is built. I add the dependency to my Che. Now I need to create a custom assembly. So it will be a completely new Che assembly, which will include our new extension. So at first, I will start by building my assembly IDE war, and then I will rebuild my assembly main. And once I have that, I can run my sample and my custom Che. So let's do that. So I'm going to share my screen. So I already built it, and it is running on my local machine. So what I will do is that I will create a new workspace. I will select the Java runtime, create the workspace, and now I will run it. And I will open it. While I will open it, the IDE application is initialized, the workspace is starting, but while the IDE was initialized, the extension has been injected, and the hello world message has been displayed. So that's it. That's the few steps that you need to complete in order to create an extension inside of Che. So now let's go a little bit deeper into Che's heart by exploring two different use cases. So the first one will be handled by Jonas. He will describe how he built an e-core editor. And then Keloyan will do an experience report on adding PHP support to Che. So, Jonas, it's all you.
Hello, thank you for the introduction, and hello from Munich. I'm Jonas, working at Eclipse Source, and I would like to talk about an eco editor that we have built based on Che. So let me switch to the slides. So to give you a short background on what we did, we at Eclipse Source, we have a strong focus on the traditional desktop IDE, and we have built a lot of extension for that. And with the introduction of Eclipse Che, this is a very interesting platform for us. So we wanted to learn how to build extensions for it and gather experience about that. So we selected a use case. The use case is an existing tool which is available for the desktop IDE, and we wanted to migrate or re-implement that for Che. So what I would like to tell you is the experiences that we made and how it was possible for us to even reuse most of the existing code. About the tool itself, most of you might not be familiar with eCore. That's part of the Eclipse modeling framework. If you don't know it, you can just assume it to be something like XSD. What we see on the slide is what we call a model. It's a definition of entities, and what you can do with that is you can generate Java code. The Java code will contain something like Java beans, so you don't have to write those classes manually, but you can generate from the code. From a tool perspective, the main two parts of the eCore tooling is first this editor. It's a tree-based editor where you can drag and drop, you can create entities, and you can modify the properties. So for example, what we see here are three entities: task, user, user group of a simple data model. And the second step is you can generate code from that. And those are the main two use cases that we wanted to implement in Che 2. So let's have a quick overview of the detailed use case. First of all, we wanted to be able to create a custom project type. We called it a model project. Second, we wanted to be able to create such an eCore file, which contains a custom model. We want to load and save this eCore model. We want to provide CRUD. That means we want to enable the user to create, read, update, and delete this file in a tree-based editor. And finally, we want to generate code. Now, important for the rest of the presentation, I will not go into detail about eCore. I believe that the use cases that we have here are applicable for many different kinds of tools. So I will focus on the generic stuff to tell you what you can do if you want to support your own tooling, rather than going into detail about what this really means in eCore. Okay, so let's start with the first one. The goal is that we extend Che in a way that we can create a custom project type, preferably with custom settings and ideally with existing example code, so the user already has a template to start from. So Che is extensible for that. Stefan has already introduced a first simple extension mechanism using dependency injection. In his example, he injected a service, the notification manager, and then he called that service to do something in the Che IDE. This extension mechanism is used heavily in Che. So for example, if you want to place menu items and those things, then you can just inject the service and use its API. There is a second usage of dependency injection if you want to register new types. For example, a project type that you can see on the slide. In this case, we implement typically a given Che interface. So for example, if we want to register a custom project type, we implement the interface project type given by Che in our plugin. And our custom class is then my project type. That's pretty simple. And now we have to register our implementation of a project type for the platform. And for that, the standard dependency injection mechanism of gin or juice is used, gin on the client and juice on the server. So we bind our implementation into the dependency injection context, and from there it can be picked up by Che to show, for example, our project type in the creation menu. So let's have a look at a code example for that. So here we have our project type. It extends the existing Che project type def. We just need a constructor to specify some properties, for example, an ID, the title, some configuration. We can add more here. I will not go too much into detail, but if we want to store a certain property in this project type, we can add it as a variable definition. So that's the first part, defining the project type. And then we have to register this project type using standard juice dependency injection. So we create a binder for the interface project type def. That's the interface defined by Che. And then we add a binding to our concrete implementation of that, which is the subclass that we provide over here. And just with this registration, the new project type would be picked up by Che. Let me show you the result in a running Che instance. So let me share that. So if we add the code described before and then run Che, we would have a new entry in the create project menu. So for example, all those existing project types have been added exactly the same. And by default, you already get a name and a description that you can add. For our eCore extension, we used even a better extension mechanism for our use case, because we wanted to enable the user to create a project which already contains some example content. And that's also possible in Che. When I scroll down, you see there is a list of samples. Those samples are actually not deployed with Che, but they are retrieved from different online repositories. To add such a sample, the only thing that you need to do is add a Git repository URL to Che, and then users can directly instantiate those examples from your online repository. The huge advantage of that is that you can maintain the samples independently of the IDE deployment. So if we want to change something there, we can simply push to our Git repository and all users will automatically use the updated version. So let me create such a project. So now it gets in contact with our online repository, and then create my example project. And as you can see, the samples already contain 3 different projects. That's the template that we wanted. And we can see there are already some files in here. So the user is basically ready to go and doesn't need to set up all those configuration files. Okay, let me switch back to the slides. Okay, so next step is to register a custom file type. The file type registration is pretty much the same as the project type registration, so I won't repeat that. The only missing piece then for the file is to add a new file action, because we want to enable the user to create such new files, in our case an eCore file. The good thing is that for those standard action, in our case to create a file, Che provides existing abstract classes. So here we have a create my file action, which extends from abstract new resource action. So that's given by Che. And we just need to specify a description for that action and a file extension. And then that's all we need to do to enable the user to create a new file. So let me demo that again. So now in our project, when I click on new, we have added an entry here to create such an eCore file. I can enter a name. And let me close this for now. And then you see we have a custom file type. It has a custom icon, and you can also provide some template content. Now, the next interesting question is, of course, after creating a file, how to modify it in the middle. If you don't do anything there, I will simulate that by renaming this file to eco1. So now it's a file type which is unknown to Che, and open it. You will see that Che can open all text files with a standard editor. This standard editor is provided by Orion, or it uses the Orion framework. It's pretty powerful, but it's based on text. So for our use case, it was not the perfect match. So let's discuss what different choices you have when you want to implement an editor for Che. First obvious choice, if you want to do anything related to text, is to use this Orion editor that I've just shown in the demo. It provides out-of-the-box supports for most common languages like XML, Java, JavaScript, and so on. And it can even be extended. So it's a framework by itself. So if a language is missing, you can add language support directly to the underlying Orion editor. The preferred way nowadays, I would say, to do that would be to use the language server protocol. Because if there's a language server available for your language, you just need to connect it. If there's no server available for your language, you might consider to write one, because then you can reuse this language support in other tools too. So it's a pretty flexible way. I don't have the time to go into detail, but that's definitely the preferred way to provide support for new languages. And finally, Che provides an additional API on top of the Orion editor to adapt things like code completion, quick fixes, syntax highlighting, and all the features that you typically want in a powerful language editor when we deal with text. Now, in our case, as shown on the first screenshot, we don't want to deal directly with text, but we want to have a tree-based editor. Additionally, we want to display some forms for the user to enter properties. Now, for that use cases, for that use case, there are two ways you can go. First, as Stefan mentioned before, you can implement your own component in Grid. So as Che is written in GWT, you can just add a custom component. There's a API to add your own editor, and if you're familiar with Grid, it's pretty simple to implement whatever you want and show it in the IDE. Now, one of our goals was to implement as few code as possible and to reuse other existing components. So we didn't want to write a new component in GWT. What we wanted to do is to embed an existing editor, and more precisely, an existing editor which is based on HTML and JavaScript. And as Che, at the IDE at the end of the day, is a browser application, that's possible, and it's even supported well. And that enables us to use any existing UI component which you can embed and which is based on HTML and JavaScript. So that's the third choice is the one that we took, and let's have a more detailed look at that one. The framework or the component that we wanted to embed is called JSON Forms. I will not go into detail about that. That's framework which makes it pretty efficient to write tree and form-based UIs. So basically, you just need to provide a JSON schema, and then you get for free a tree and a detailed view. So if you look at the screenshot below, that's pretty much what we want for our eco editor. So that's why this framework was a good fit. Now, the interesting part is how to embed this into Che. What we see here is a conceptual overview. I will start at the bottom. When you extend Che by a new UI component, a view, this view will then create an HTML element when the application starts, when the IDE starts. Now, what we did is we added a view which just creates an empty placeholder here. So it doesn't really render the UI itself. It just creates a placeholder with a given ID, so we know where exactly in the HTML DOM we want to place our extension. And then we added what we call a presenter, in this example, Hello World presenter, which uses the GWT capabilities to add a JavaScript file to the rendered HTML window. And then this JavaScript can access the existing HTML element and thereby modify the DOM. And this provides now full access to our HTML DOM, so we can basically do whatever we want here. In our case, we replace this HTML element with the component that we want to embed at this place. Now, the final missing piece is only embedding the component would be nice, but then it's not connected to the data. So we need a way to pass input to our editor. And for that, again, we use a nice GWT capability. We create a class called overlay, which provides a Java API, as GWT applications are implemented in Java. And it forwards those calls to our JavaScript. So basically what we can do here, for example, is to provide a method setInput, and this will then be forwarded to our JavaScript. And then this JavaScript API or this JavaScript component can fill our HTML element with any input that we want. If you're interested in this approach, it's part of the Che extension documentation. Okay, so let's have a look at that in the running IDE. So now let me close this standard text editor and browse to a real eco file. And now when I double click this, we see here it's a little bit small. We see now we have here in the middle the tree-based editor. We didn't spend much time on polishing it, but it works pretty much out of the box. So only by embedding this existing component, we have features like, or we can see all attributes. So for example, if I rename this class to task 1 to 3, data binding is there. We can look at all the sub-elements. We can even create new elements. So it's to be usable in a real context, we would have to apply some polishing, but the CRUD use case is definitely there. So all the attributes can be modified. Okay, so let's switch back to my slides. So one missing piece that I didn't mention is that our component that we used for the UI creation on the client consumes a JSON, while eCore on the server, the eCore file contains an XML format. So to use this existing UI component, we have to convert from XML to JSON. And that's a good use case, or that was a good use case for a server extension. As Stefan mentioned before, you can either extend the client, but also the server. So what we did is we created a server plugin, which contains a JSON to eCore converter. That's basically a REST service. The JSON eCore converter service accesses the workspace using a given Che service, the file service. So it gets the content of the eCore file. It transforms that to JSON. That's a pretty simple operation. And now our eCore editor is directly talking to this JSON eCore converter. And that's a pretty simple way of transforming the input to our target format. Okay, and finally, or the final step of our use case, after enabling the user to create eCore files and modify them, we want to allow the user to generate code from that. Again, for this use case, it's already supported in the desktop IDE, and there is an existing, or the existing framework provides a code generator. So rewriting this code generator would be really a lot of effort. So we definitely wanted to reuse it. Now, there are two ways to reuse such existing tools. The first one would be, again, to create a service running on the server, which provides a REST API. And this service now could use the Java API of existing tools to trigger any operation. That works well if the existing tooling provides a suitable Java API. So if you want to do something with any tool implemented in Java, that's pretty simple to do. And now we could trigger this service from an action in our IDE again. Now there's even a simpler way of integrating. If your existing tool can be executed on the command line, and that's the case for the EMF code generator, you can just install the tool into your workspace, and that's pretty simple because those are just Docker containers, so we can configure anything to be installed here in our workspace. We can then directly trigger this tool from an action and execute it directly on the workspace. And in our case, this was the case, so that eCore can be executed on the command line. And that's a very simple but still powerful way of integrating. So let me show that in the IDE. Okay, so let's close this and make this a little bit bigger. So what we see down here is the terminal, which is the direct way to trigger commands on our workspace. So for example, if my workspace contains Maven, I could just trigger manually a command here, and it would directly show me the result. So I could, for example, trigger a build. Now, if I would know how to trigger the code generation, I could manually do that. However, we don't want to make it so difficult for the user. We want to integrate the operation into the UI. Now, there are two ways to do that. If users know exactly what they do, they can define their own commands. So that can be done in this menu here. So if you have a command that you need to trigger more often, for example, the standard build, you can just add it here and then directly trigger it from this menu. However, in our case, we even want to have a right-click menu because users should not be forced to always add their own commands if they want to generate code. So what we did is we added a action in the right-click menu. So you see there is an EMF submenu here, and we have an action called Run Code Generator. And now if I run this, you see there is a command triggered in a new console. That's the command. So it contains some properties. And now on the workspace, the EMF code generation is started. That will take a few seconds. Now it starts to generate the code. So that will produce sources in this project. Currently, there are no sources. So code generation is running. And the nice thing is that Che automatically detects that there are new files in this project, so we don't have to do anything to make the source code visible then. And now we can browse in here and look at the generated code. I will not go into detail, but just as you see, now we generated Java code and completely reused the existing generator. Okay, so that was almost it. Let me conclude and share the last slide. So we really enjoyed working with Che. There's a great API, and the dependency injection mechanism makes it very flexible. I would like to highlight two main things. The first one is that I would highly recommend to reuse existing HTML components if possible, because you can save a lot of effort there. Another advantage of that is that your components, if you need to develop a new editor, for example, you can also use it standalone. So it cannot only be consumed in Che, but also outside of Che. And the second recommendation is try to use existing tools, and the command line as an example is a pretty good way of integrating that. So if you're interested in more information, unfortunately we did not publish our extension yet, but we plan to do so in the next days. So if you're interested in that, follow me on Twitter or drop me an email. And now I thank the audience and Stefan for the introduction, and I would like to hand over to the next speaker, which is Kilo-Jan.
Thank you, Jonas. So now let's take a look what does it take to implement a new programming language in Che. I'm with Zend, which is known as the PHP company, and our mission is to develop tools for PHP developers and provide them with a set of first-class tools. And we're doing this for quite a long time. We're contributing PHP tools to the Eclipse IDE for long years. They are known as the Eclipse PDT project. And now we are taking the opportunity to make the same for Che. So our experience with implementing the PHP support can be summarized in the following list of items. First, we had to take care about some basics. We defined the PHP project type and made sure that the code editor has the appropriate syntax highlighting for the various PHP types, PHP file types. Then we added a new stack with Zen Server, which is a professional and certified PHP stack. And we added it in addition to the existing default PHP stack. In the Zen Server stack, we have more things available out of the box as debuggers and PHP extensions and so on. Then we added a richer set of project samples to be easier to explore the Che capabilities with some real code. Next, we started looking at implementing IntelliSense. Luckily, at that time, Che was in progress of adopting the language server protocol. And there were a couple of PHP language servers in progress of development. So we took advantage of these existing assets. I'll tell you about this in a few minutes. Finally, we integrated a PHP debugger to complete the critical set of development tools. Along the way, we identified and fixed some little things in Che for better results of our integration efforts. Such things always happen when you're introducing a new scenario in an existing platform. I can say that it was a great experience to work with the Che community for fixing these issues instead of trying to implement some hacky workarounds. Let's now have a look at some code. When you implement a new project type, you need to take care for the so-called project generator. This is a class that implements the create project handler interface and is invoked when the user creates a new empty project of that project type. In the PHP project generator, we simply retrieve the IDE's virtual file system. We add a new folder for the new project, and then we create some file like hello.php with some default content like hello world. The virtual file system is retrieved by the respective provider, which is injected in this same class. The dependency injection makes it really easy. The syntax highlighting in Che is provided by the Orion editor. It already provides highlighting for many file extensions. If you don't see it for your file extension, then you might have a look at this extension file type identifier class. In our case, we were missing the mapping for the phtml extension, which is the file extension for PHP templates, a mixture of PHP and HTML code. So in the end, we had to add this mapping in this class as well, and voila, the highlighting was available. New stacks are defined in a JSON file like this. It may look quite complex, but in general, you copy this definition from an existing stack, and then you adjust the properties that you need. Here you need to change the ID, the name, and the description. And then you might want to review the list of the agents and have only this that makes sense to be enabled for your stack. The workspace agent is mandatory. The terminal and the SSH agent are usually enabled for all stacks. And for the PHP stack, we also have the agents for the PHP and the JSON language servers. Next, you need to define the Docker image that brings the runtime of the stack. For our Zen stack, this is an image with Zen server that is automatically bootstrapped and ready to use in the Docker container. And finally, you may define some commands that provide helpful actions for managing the runtime components. Here we have an example command that prints the admin password of the Zen server's admin UI. You need to print it because it's automatically generated when you start the workspace. And then in the preview link, we print the URL to the admin UI itself. Here we use a macros that will actually resolve to the actual exposed port number 181. In a similar JSON file, you can also define project samples. IntelliSense in Che is provided by language servers. At least this is the new trend. For older implementations of languages like Java and C, I think they're still not using the language servers, but for every new language, it's the language server that is used. There is a language server for PHP as well, and it evolves pretty fast and already provides the most important IntelliSense features like code completion, syntax validation, formatting, finding symbols, code navigation, and others. However, the most important feature of this language server is that it is implemented in pure PHP. This allows reusing existing PHP tools. We use the PHP parser for parsing the PHP code, as well as for the syntax validation. PHP code sniffer is used for the code formatting, and we plan to use code sniffer also for static code analysis in the near future. Other PHP tools like the PHP mess detector are also good candidates to be used in the PHP language server. Another benefit of having the language server implemented in pure PHP is that it dramatically lowers the contribution bar of PHP developers. Think about it. So far, all popular PHP IDEs and editors were implemented in Java or C. Now this is about to change. If you're a PHP developer, you can now go ahead and use your PHP skills to improve your IDE by contributing to the PHP language server. You can see the link to the project below on the slide. And of course, it's open source. Now we have the language server, and let's see how Che launches it. You need to implement a language server launcher for your language server. It starts the language server as a child process. The input and output streams of the parent and the child processes are connected via pipe. And this acts as the communication channel between Che and the language server. The actual code that initializes the language server is provided by a launch shell script. This shell script is provided by an agent. As you remember, we defined what agents are enabled in the stack definition. Each language server has its own agent. The agent is a script that injects resources in the workspace machine. Here, the PHP language server agent downloads the binaries of the language server from a central repository. This is the CodeEnvy repository at the top of the slide. Then it extracts it, creates the launch script. If I can point to it, here is the launch command itself. Here we actually invoke the PHP executable, which calls the PHP file with the entry point, and then it writes it to this launch.sh script file. And in the previous slide, you saw that this is actually the shell script that is executed by Che. Let me now say a few words about the debugger. Those who are familiar with the PHP language know that unlike other languages, PHP has several debugger implementations. As a first step, we integrated Zen Debugger. Our future plans include integrating Xdebug too. The first step for implementing the debugger support is to build the debug configuration page. And it contains important user settings like the break at first line option or the host and port where the debugger listens for new debug sessions. Then you need to define the debugger factory. This is a factory class that uses the user settings from the debug configuration page and initializes the actual debugger implementation class with these settings. The factory class is bound in the debugger module configuration, so it appears as an available debugger type. This way, it's possible to extend with new debugger types. So on the previous slide, we saw that we have one for Node.js, one for PHP, for Java, and a GDB debugger for C. The debugger implementation class implements the debugger interface. The interface defines a list of methods that we can separate in the following groups. First, we have methods for starting and disconnecting a debug session, as well as getting debug info about the session connection like host and port. Then we have a set of methods for managing the breakpoints. Next are the methods for working with the variables available in the current stack frame. And finally, we have the methods for progressing in the code execution, like stepping over, stepping into, and etc. This is all from me about our experience in improving the PHP support in Che. I hope it was helpful information for those of you who plan to introduce a new programming language in Che. And thanks for watching, and handing over to you, Stefan.
Thank you. Thanks. So I will conclude this session by showing the links to the documentation. So you will find on our documentation website a whole set of documentation about authoring extensions. So it covers the aspect of the IDE setup, how to build the extension, what are the assemblies, how the dependency injection is working. And then you have all sorts of tutorial style documentation about creating custom editors, adding a custom project type, registering some actions, services that are both running on the server, on Che server or inside of the workspace, and how to extend the UI as well. So I really recommend you to give a look into this documentation to learn more about the Che extensibility model. You will also be able to explore all the samples extensions that are provided with Che. So they are on the repository of Che, so github.com eclipse/Che, and it is inside of the sample folder. So you will find some sample code to get started and get hands-on. And I would like to say a big thank you to our two guest speakers today. So thanks, Jonas, thanks, Keloyan, and thanks for all our attendees. So thank you.
So this concludes our presentation with Jonas, Keloyan, Stephen on extending Che. James will be hosting this deploying Che to OpenShift with Mario from Red Hat, our founder Tyler with CodeEnvy, in just a moment. You'll be automatically redirected to these next sessions. Thank you for being a part of the Che Conference 2016.